Welcome to this channel. Okay. Hi everyone once again. In the previous video we discussed about the P block elements under the 15th group elements. In this class we are going to discuss about the compounds of group 15th elements. Okay. The previous video we had a discussion over the chemical property and physical properties of these elements. Just I recall whatever the elements are there. Group 15th elements are nitrogen, phosphorus, arsenic, antimony and bismuth. So these are the group 15th elements. These elements has different physical and chemical property, and the nitrogen itself shows different behavior compared to the elements of other. Because of that, these behavior, the difference in the behavior is considered as a anomalous property or anomalous behavior of nitrogen. There are several anomalous behaviors are there, but there are 5 important anomalous behaviors discussed in the previous class. Just recall whatever the important anomalous behavior of nitrogen. Okay. The nitrogen is very smaller and absence of d block elements and more electronegativity. Because of that, it shows some anomalous behavior. The anomalous properties of nitrogen are: first one, it is very smaller, because of that it is gas, while other elements are solids. And nitrogen is more stable and it shows nitrogen triple bond, but in other cases only single bonds. Next, nitrogen does not shows pentavalent. Okay, other element shows pentavalent because of the absence of d orbital. So absence of d orbital, it can't show the pentavalency. Okay, but oxidation state is possible. Okay. Next, nitrogen, the compounds of nitrogen, ammonia, is liquid, but other hydrides, okay, or hydrides of in the other elements, ammonia, phosphine and hydrides of arsenic and antimony. The hydrides of nitrogen is liquid and shows hydrogen bonding, but hydrides of other element does not shows any hydrogen bonding. Bond dissociation enthalpy of nitrogen is very high compared to other because of the smaller size and the triple bond. And there is a possibility of formation of p pi bond in the nitrogen, but there is no p pi d pi or d pi bond in nitrogen. But other may forms or shows p pi d pi and d pi bonds. Okay, because of the presence of d orbital. The pi bond formed by the overlap of d orbitals also. It's it considered as p pi d phi bond or d pi bonds. Okay. So in case of nitrogen, absence of d orbital, only p3. Okay, p orbitals are available. The p orbital, they undergo overlap. Head-on overlap leads to formation of a sigma bond, and the p of one nitrogen, p of another nitrogen, they undergo lateral overlap or sideway overlap, that leads to pi bond. P pi bond is formed, but because of the absence of d orbital, there is no p pi d phi or d phi bonds. Okay, so these are the very important concept or anomalous behavior of nitrogen. Any three anomalous behaviors enough for your exam. Okay, let us move on to the compounds of the group 15th elements. What are the group 15th elements? Okay, these nitrogen, phosphorus, arsenic, they form different compounds. Okay, the first very important compound is formed from nitrogen. It is known as or called as dinitrogen. So in the anomalous behavior of nitrogen, we we discussed one thing. A nitrogen is diatomic. Correct. It is diatomicity. It shows diatomicity, but other shows polyatomicity. Okay. Nitrogen shows diatomicity, other shows polyatomicity, as well as nitrogen does not show any allotrophies, but other shows allotrophy nature. Okay. There is a possibility of allotrophies of phosphorus, but nitrogen does not show. Okay. Nitrogen shows diatomicity and other shows polyatomicity. Nitrogen shows diatomicity because of that. Also, in the standard condition or in atmospheric condition, nitrogen exists in the form of dinitrogen. Okay. Dinitrogen is nothing but nitrogen, but exists in the form of N2 because of very smaller, and the possibility of nitrogen triple bond. This one is more stable, hence it exists in the form of N2 state. Okay, as similar as that of the oxygen. Oxygen atomic state is not observed; it is always present in the molecular state. Similarly, nitrogen exists in the molecular state. The molecular state of nitrogen is N2. Okay, it is known as dinitrogen. Okay, nitrogen is nothing but dinitrogen. Okay, both the name is used in a commonly we called as nitrogen, but in a chemically it is considered as a dinitrogen. Let us discuss about the preparation and properties of this dinitrogen. Okay, how to prepare? What are the methods involved in the preparation of nitrogen, dinitrogen? The preparation of dinitrogen. Method of preparation of dinitrogen. There are several methods. Some or few method of preparation is considered as laboratory preparation, and few methods are considered as industrial level. Suppose we use laboratory reagents or the chemical reagents that are available in the lab or laboratory. That method is known as laboratory method, and the large quantity of the preparation. Suppose that the preparation involves a large scale, that is considered as industrial method of preparation. The laboratory preparation of dinitrogen is using ammonium chloride. Okay, using ammonium chloride. First method is method of preparation. The first one is from ammonium chloride. Okay. There are three important methods given in your syllabus. Okay, these methods of preparations is not much important. About dinitrogen is not much important, but knowledge purpose we need to the method. Okay, what happened in case of preparation when ammonium chloride use dinitrogen? Okay, which reagent is required? Okay, here we observe chloride. Therefore, we need a metal compound or metallic compounds are required. Therefore, we consider sodium nitrate. What happened in this case? When ammonium chloride is made to react with sodium or treated with sodium nitrite. Okay, please remember the name of the compound. It is sodium nitrite, not nitrate. Okay, NaNO2 is nitrite, NaNO3 is nitrate. This one is nitrite. When ammonium chloride is made to react with, or these two compounds are undergo a reaction, gives N2, nothing but dinitrogen. And how it comes? Nitrogen, N2 is evolved in water and oxygen. How much quantity? Therefore, quantity of hydrogen remaining thing is sodium chloride. Okay, sodium chloride. So this is the reaction. This is the nitrogen. This is the method of preparation of dinitrogen using laboratory methods. Okay, dinitrogen is obtained from ammonium chloride treating with sodium nitrite. Okay, so this is the one method of preparation of dinitrogen. I am consider another method. The second method of preparation of nitrogen is from decomposition of ammonium chromate or dichromate. Okay, Na2Cr2O7, NH4 twice Cr2O7, nothing but ammonium dichromate. Okay, dichromate. This ammonium dichromate, when undergo decomposition means itself it undergo breaking of bond or bond breaking take place itself or auto breaking of bonds. In this case, little bit amount of energy is required. This energy is supplied through heat. Okay, whenever ammonium dichromate is heated, little bit heat is supplied. Happen NH4 twice. Remember the name and the formula. Cr2O7 ammonium dichromate is heated, thermal decomposition. It gives dinitrogen. Yes, nitrogen from this. And what are the things remaining? NH4 twice O3, so therefore it is H2O is evaporated or water vapor evaporated when it is heated. 4 into 2, how much quantity of hydrogen is there? So 4 into 2, 8 hydrogen. So therefore 4 quantity of water is evaporated. How much quantity of oxygen required for 4 molecule of water? 4 oxygen get lost from 7, 3 remaining. So it becomes Cr2O3 chromic acid is the byproduct. Okay, dinitrogen is formed. Nitrogen is isolated or separated from this compound, and this once again it becomes the laboratory method. So you see ammonium dichromate. Okay, these two laboratory method of preparation, and another one is there a large quantity of very pure dinitrogen is obtained from. You are well known about the nitrogen. So nitrogen is the most abundant elements in the atmosphere. Around 70% by mass quantity is observed in atmosphere. Because of that, the preparation of nitrogen is not required commonly because it is easily available element or molecule. But pure nitrogen, suppose we need pure nitrogen, then we use azides. Okay, mainly barium azides. Okay, azides. What is the meaning of azides? Azo, that means N2, correct? Azides N3. Okay, there are several methyl azides and consider barium azides. Okay, BaN3 twice. When barium azides is again thermal, suppose it is subjected to thermal decomposition, then it gives nitrogen. Pure nitrogen is obtained and the barium. Okay, 3 into 2, 3 into 2. So this much quantity of nitrogen evolved from this barium azides and barium is separated. So this is the pure nitrogen obtained in this method. Okay, there is a possibility of asking the question based on this purity of nitrogen. Which method is suitable to obtain the pure nitrogen in lab or laboratory preparation? From barium azide or metal azides. Okay, not only barium, mainly barium azides because of the availability of azides. Barium azides available, so that we consider the barium. Okay, the barium azides gives nitrogen this reaction, in this reaction we observe or obtain the pure nitrogen. Okay, pure nitrogen is obtained. So these are the three important preparation of dinitrogen. Okay, there are three important preparation. One is from ammonium chloride, second one is ammonium dichromate, third one is barium azide. Okay, so these three are the preparation method of nitrogen. Next we move on to the properties of dinitrogen. Okay, properties of dinitrogen. Here or in this topic we follow the same manner or same things repeatedly we observe. In this case, P block elements, the 15th group 15th elements, nitrogen, phosphorus, arsenic, antimony, bismuth. What are the occurrence or method of preparation? And the next thing is property. Next thing is use. Similarly, compounds of 15th group elements also. I am considering first one compound is nitrogen or dinitrogen. This dinitrogen involves under this topic or under this part we discussed about the preparation method, properties and next use. Similarly, next move on to another compound. Next the preparation method of that compound. Next the properties of that compound and next is the use. Okay. So same thing we observe repeatedly in this topic. Little bit easy compared to the other topic. Okay, suppose we give the more concentration in this part. Properties of dinitrogen. So what are the properties? There are several properties. I am considering the few physical properties of dinitrogen. Dinitrogen is colorless, odorless and tasteless, non-toxic gas. Okay, what is the physical condition of nitrogen? It is gas. Okay, physical state is gaseous state, colorless, odorless, tasteless. Then question arises, sir, here taste the nitrogen, is it possible? Yes, possible. When we liquefy the compound or gas, when we liquefy the dinitrogen, then possibility of tasting the dinitrogen. So it is already tasted as few scientists or observers. It is tasteless, next odorless, it is colorless. Okay, so we commonly know the dinitrogen. The more quantity of nitrogen is present in here or in atmosphere, there is no colored gas is observed. Because of that, there is no color, odorless, there is no odor in this gas and also tasteless. Suppose it hasn't taste, then when gas passes near your tongue, then we feel some taste, or suppose it is toxic, then very difficulty to live here. And odor, there is no odor. If suppose nitrogen has odor, then full of atmosphere is odor of the nitrogen, become odor of nitrogen. And colorless, suppose it has color, then atmosphere look like different color. So there is no possibility of all these things. Therefore, it is colorless, odorless, tasteless, and non-toxic gas. And the next thing is solubility, less soluble in or poor solubility is observed, less soluble in water. Okay, so solubility of nitrogen is less compared to the oxygen. Oxygen is more soluble in water compared to the nitrogen. So that is the another important property, and it is non-metallic compound, non-metallic element. Okay. Next, it reacts with few metal and form nitrites. Can anybody guess the product and which element or which metal forms a nitrite? You are sitting in a first year. Formation of a nitrites from a metallic compound that from S block elements. In the S block elements, yes, you are correct. Lithium and magnesium, when react with the nitrogen or dinitrogen and forms respective nitrides. Okay, suppose lithium is react with nitrogen. What happened? When lithium is react with nitrogen, so it forms Li3n. Okay, to balancing this equation or reaction into, so 2 next 3 to 6 quantity. Okay, so this is lithium nitride. It is nothing but lithium nitride. Suppose the magnesium, these two shows diagonal relationship. Lithium and magnesium shows diagonal relationship. The few properties of lithium is similar property observed in the magnesium also. So magnesium react with nitrogen, it forms magnesium nitride. Okay, so to balancing this equation, what are the things required? It is 3 2. Okay, so this is magnesium nitride because of oxidation state. Okay, of magnesium plus 2, lithium is plus 1. Okay, so these are the nitrides. That means lithium or magnesium react with nitrogen forms a nitrides, or it has capacity. Dinitrogen shows capacity to form a nitride, metallic nitride with the lithium and magnesium. Okay, so that is the chemical property. These are the few physical properties. Okay, so these are the important property observed in the nitrogen. Next, uses of dinitrogen. Okay, uses of dinitrogen. The important uses of dinitrogen is, it is used in the preparation of, okay, first thing is, it is used to preparation of ammonia. Preparation of ammonia, we use dinitrogen, and it is also used to store the biological thing, store the biological things or materials, and also in cryosurgery. Cryosurgery, what is the meaning of cryosurgery? The new thing. Cryosurgery is nothing but at a lower temperature. Few surgeries are conducted. So the surgery that conducted in the lower temperature, okay, that one is considered or called it as a cryosurgery. So at the lower condition or lower temperature. Okay, so this liquid dinitrogen is mainly used. Okay, in this case liquid dinitrogen is used. So these are the important things. The gaseous nitrogen is used to preparation of nitrogen as well as some fertilizers or nitrogenic compound, and store the biological things or materials, and also liquid dinitrogen is used to cryosurgery. Okay, so these are the important uses of dinitrogen. Let's move on to the second compound of nitrogen is ammonia. Okay, second compounds of the group 15th elements of the nitrogen is ammonia. Here we observe the very important concept, okay, under ammonia. Okay, ammonia concept is very important compared to nitrogen. Dinitrogen is not much important. Okay, for your exam point of view, ammonia is very important. So first, as similar as that of dinitrogen, first is the preparation part of dinitrogen. How to prepare ammonia? Okay, what is the preparation method? There are two important methods are there. First one is laboratory preparation. Laboratory preparation. In the laboratory preparation, ammonia is prepared from, again, ammonium salts and base. Okay, from ammonium salts. from ammonium salts. I am consider ammonium chloride again. Okay, don't confuse with the method of preparation of dinitrogen. Here also we consider ammonium chloride when it is treated with the mainly base. Okay, the basic solutions are treated with ammonium salt, it gives ammonia. When ammonium chloride is treated with calcium hydroxide, nothing but lime water. When lime water is made to react with ammonium chloride, then formation of ammonia. Next thing is calcium chloride, correct? Next thing is water. Then balance the equation. Ammonium chloride, calcium chloride means 2Cl. Therefore, I am considered 2 ammonia is formed. Next, the remaining thing, 4 into 2, 8 hydrogen, and the 2, 10 hydrogen is required. 6 is already goes out, and there are 2, and make it into 4. Okay, next thing is calcium. Okay, oxygen, 2 oxygen, 2 oxygen. It is balanced. This is the balanced chemical equation of preparation of ammonia from ammonium chloride. Suppose it has ammonium sulfate. Suppose in your lab there is no ammonium chloride, it has a large quantity of ammonium sulfate, then how to prepare ammonia? Preparation of ammonia from ammonium sulfate, again treated with the base. What I used the sentence in the first case, from ammonium salt treated with the base. Okay, base lime water or this one caustic soda. When ammonium hydroxide is treated with ammonium sulfate, again it gives ammonia. Next, sulfate is there and sodium is there, so therefore sodium sulfate is formed. Sodium sulfate, 2 quantities required because of 2. Next, water, balance the reaction. So 2 ammonia, therefore 2 ammonia is formed. Okay, get balanced ammonia. 8 into 2, so it is 4 into 2, 8. 8 hydrogen and 2 hydrogen. Again 10, 6 goes out, again 2, it is balanced. Okay, so this is the reaction, balanced chemical reaction of preparation of ammonia. This is the laboratory method of preparation. Please remember the thing, very important. Laboratory method of preparation of ammonia from ammonium salts. When ammonium chloride or ammonium sulfate is made to react with the bases, then that gives the ammonia. Ammonia is evolved, ammonia is liberated. Okay, let's move on to the industrial preparation of ammonia. Very important concept for your exam point of view. Okay, preparation of ammonia. Okay, it is an industrial method of preparation, and this is the very important concept and the definite question for your exam. How to prepare ammonia in industrial level in a or very commercial importance. It has commercial importance. When we give the importance to the commerciality or industrial, then the preparation of ammonia should be using the available raw material. The ammonia is prepared from raw material that are available in our atmosphere. These two things are available in atmosphere, dinitrogen as well as the dihydrogen. These two things are available in atmosphere. Using these two things, ammonia is prepared. When nitrogen and hydrogens are made to react, then it gives ammonia. When it gives ammonia, there are several conditions there. How to prepare ammonia using the atmospheric dinitrogen and the hydrogen. So, the quantity of hydrogen is required. Automatically, these two never react together. Suppose these two are react together, then In atmosphere there is a lot of ammonia. There is a possibility, correct? Nitrogen and hydrogen, these two are available in atmosphere in a large quantity. When these two, pure nitrogen and hydrogens, are made to react with the several conditions, and it is also a reversible reaction and gives ammonia, then what are the important conditions required to preparation of ammonia in this method? The important conditions are, one is temperature, moderate temperature around 700 Kelvin. Moderate temperature 700 Kelvin. Next, very high pressure. High pressure is required. It is around 200 atmosphere pressure. And the next is the catalyst is required. Catalysts are iron oxides, or in olden days molybdenum oxides also used. Okay, nowadays iron oxide is used to promote the catalyst or enhance the properties of catalyst. We use a promoter in this case. Promoter, what is the role of promoter? Increase the reactivity of catalyst. We use potassium oxide as well as alumina is used. The role of promoter, increase the activity of iron oxide. Iron oxide catalyst enhance the reaction and give the more quantity, or helps to production of more quantity of ammonia. This much temperature is required to react these two, and pressure is required. These things are required. These things are depends upon, or the principle. These things are based on the principle of Lee-Chatelier principle. In the first year topic, you are already studied Lee-Chatelier's principle. The Lee-Chatelier principle, what it says, if the reaction is reversible, to nullify the effect of these, the equilibrium shift any one side. The equilibrium shift product side, then only our intention is succeed. Correct? What is our intention? Intention is to product more quantity of this product, ammonia. When we get more quantity of product, when we use this condition. In this condition only, large quantity of ammonia is produced, and this one is delta H is negative, meaning is enthalpy is negative. Enthalpy negative means exothermic reaction. Okay, so these are the very important conditions. And the next part, how to prepare ammonia, that is studied using one chart, or in industrial level, how to prepare ammonia. It is studied using one chart that will be discussed in the next class. Okay, here I will stop the class up to the preparation and the condition of ammonia. Okay, in the next video we continue the part of this preparation of ammonia using the flow chart. Okay.